Okay, let's get this started. This is my video report. My name is Murray Campbell. Okay, so the first problem for assignment 2 was to get this star pattern to render this kind of gradient looking star. So I'm going to show that really quick. In the last video I didn't show the second question, but I did get that running. I just forgot to show it, so that's my bad. But I'll make sure to run every project before I talk about it. So here we have the desired effect, right? That's all good. We'll just go in here and explain that solving this problem basically just involved assigning, it's kind of just like what you were talking about in class. We assign color values to specific vertices. Not very much else changed here. You can see I also changed the shader to use Simple Color Plus, and that's the one that uses that can basically take in color like that. I don't know. This is the one that worked. Yeah, moving on anyways. In question 2, we had to render that star pattern. The one that, so that just involved, while I'm running this, I'll just show it. This one just involved having a lot of extra vertices, so we rendered a few distinct triangles that almost seem separate from each other. So we have the effect here. I'll show that. Like before, you can see we have the simple vertex struct that has just the position and a color, and then that gets set here, and you can see just have I did like top, right, bottom, left points of the star, and then I did the middle square. Then I just set up the indices correctly. Pretty straightforward. I had to update this. Also made sure to update everything to use the simple vertex struct when doing size of, stuff like that. And that rendered just fine. I showed that right. I'll just run it one more time to be sure. So there's that. Yeah. Cool. Moving on. The next problem was about modifying this. Oh, it was like changing the ordering of, hang on, A2, Q3. So I'll just make sure you know that it works on my end. See, so you can see things working there. Normally it would like throw an error. So if I go into DXApp here, what I ended up, so I changed everything to the correct ordering, so the colors came first instead of the vector. That's reflected here as well in the simple vertex, so it's color then position. And what I had to change was this. It was the layout, the input layout. So I had to basically switch color and position here. They're using the same formats. Not much else had to get changed. So I'm passing in the color first and then the position, and so that goes into the shader correctly. Because these are the semantics. I realized that like the semantics aren't like shader standard. They're specific to you. So you set these, right? No, maybe not. Maybe that's not true. But I was able to set, maybe there are default ones, but you can set specific ones, because I was able to set an index value in the next question, and I'll show you. So for the final problem, we had to render this, and we changed the CB color struct and to have like indices that you could specify here by just setting a color number. So you can see that here, this one took me the longest to figure out, but when I did, it kind of just clicked for me. So here's the simple vertex, the integer color number, Yeah, all of that. We go down here, you can see I'm setting this correctly here, just like you wanted. Gotta make sure that I am setting the constant buffer up to the vertex shader up to the constant buffer. That was something that I had to do to get things worked, specifically to get the color values coming in for, like in the invertices, like the vertex data here, getting this information to come in, and for me to be able to like change the color in the vertex shader. So you can see that here I have an index, an unsigned integer index value in the vertex data struct, and that gets put into the call buff. So this is the constant buffer here, right? And then the revelation for me, I couldn't figure this out for a while, but it was realizing that I didn't need color here because this is the vertex input layout, right? And the vertex input layout is basically this. I didn't need a color per se because the color was coming from this color buffer. So I changed this to index, and then I realized that I needed to create, I was reading the textbook, and I realized that I could create semantics like this, right? So there's that's like the index semantic. I had to change the format to just an unsigned integer, obviously. So that's what you were saying about all of the formats and us having to learn them. It's because we need to be able to pass in specific data structures into shaders, and that's like what we use is like all of these different, it's basically just types, you know. But it's wrapped, obviously it needs to be wrapped. It's all aligned, that's all good, so that works, right? I don't know if I showed it. So I'm showing it now. There, you can see. So there it is. That's running perfectly, and you can change the colors down here, and it works. Like I could change this to blue, you know, or whatever, you know. Yeah, you can tell it's working. So let me just get out of this, and I can talk about the further questions. All good? All good. Okay. So the first further question was, what's the difference between constant buffers and shader constants? I was thinking about that. I basically saw it as, from my reading, that the constant buffer is what houses the shader constants. I showed you like the shader before, the C buffer, and it's almost like a struct that just houses those constants. So those are what gets used in the shader, and you can pass in that data outside of the shader. So the constant buffer is like the housing unit. I wrote here the housing unit for shader constants, but yeah, so it's sent through the program in a buffer specifically for this purpose, and that was that. So then for this one was pretty simple, or it made sense to me immediately in my head. Was just like, well, the vertex shader, you know, like the shader stuff here is not affecting like the screen space, you know, it's not affecting the entire screen space. The shader, like the vertex shader, pixel shader, the reason like why it's doing that, why it's doing this specifically is because you know, we're passing in vertices and indices to the renderer, right? And then the shader is telling the GPU exactly like what to do with those vertices and stuff like that. So it's specific, like everything is specific to the graphical objects that you're trying to represent, that you're trying to draw on the screen, and not the entire screen. So you can see like it's whiting out around the edges of the triangle, but not the screen, because that makes sense. It's like in the triangle itself. It's housed within the triangle. And that kind of made sense to me because of just like working with shaders typically in Unity, you know, it's like it applies to the material that you apply to the object, you know, and it's like housed within the one graphical object that you're drawing. So there's that. That's pretty much it. Yeah. Oh yeah, and you mentioned it has nothing to do with the math above, and yeah, it really doesn't. This math, like, yeah, it's like the math that you're looking for. It's just not. We're not doing a screen space shader. Okay, that's all. Thank you.